Alright, so this is the video for the study guide for trimester number 3. So let's get through it one problem at a time. There are 14 problems on each of your study guides, depending on which period you're in. The first one here, we have a ratio, and you're told to find 4 equivalent ratios to the one you're given. And there are many ways to go about this, and I didn't make this one especially easy because I figure if you practice with the difficult problems, you'll have an easier time with something easier on the quiz. Now you could have either divided, multiplied both sides by 3, divided, multiplied both sides by 2. Lots of ways to go here. Let's say I'm going to go ahead and divide both sides by 3 and multiply both sides by 3 as well. So first let's go ahead and divide on the left side. 9 divided by 3 is 3. 15 divided by 3 is 5. Here it becomes a little tougher. Why? Well, because my next step is to divide both of these by 3 again. 3 divided by 3 is 1. 5 divided by 3, on the other hand, that's not going to work out evenly for you. You're going to get a decimal. And obviously not as pretty or not as comfortable to work with as whole numbers, but it's okay. Decimals shouldn't scare you. So what is 5 divided by 3? Well, if you chose to go with my root, you would have 1.7 or 1.6, depending how you round it. You could have also divided both top and bottom by 2. That would have worked, or 1.5, or something else. This is just one way to go about it. Then if I go in the opposite direction, again I'm going to multiply by 3 both sides, top and bottom. Here I'm going to get 27 over 45. And then next I'm going to get 81 over, and what's 45 times 3, anyone? And again, if you went with my method, it's 135. And again, you could have chosen something else. And as long as you have 4 equivalent ratios, yours could be as different from mine as possible. Any questions? Alright, moving on to the next problem here. You're asked to estimate the possible root answer. Now, neither 30 or 91 are perfect squares. So what we do is we find estimates, or 2 roots between which these two lie. So what are the 2 perfect squares between which 30 lies? So the smaller and the greater for 30. Well, 30 is right in between 25 and 36. And what are the root answers for 25 and 36? For 25 it's 5. For 36 is 6. So in this case, what is my estimated answer for the root of 30? 5.6, right in between the two. Same thing for the 91. 91 is not a perfect square. But what are some perfect squares between which 91 falls between? On the lower scale we have 81. On the higher scale we have 100. And what are the root answers for each of these? For 81 it's 9. For 100 it's 10. And then of course, what is our estimate for 91? 9.5. And that's a pretty decent estimate here. Question about the second problem? Alright, let's move on then. Next problem, we have a question. How can you tell if 2 ratios are equivalent? Does anyone have an answer here? You can write 2 things here. Number 1, simplify them. So simplify them. And compare simplest forms. And obviously if they're the same, then they're equivalent. Now something else you can do, and actually a few of you have done this on the previous quiz, is cross multiply the two ratios, and if the product of the cross multiplication are the same, then again they're equivalent. So you have two choices. You can either simplify them, or if you don't like breaking things down and canceling things, you can just cross multiply them. That's going to give you bigger numbers to deal with, but you know, for some that might be preferable. I would take either way. Next question. We have a word problem here, and it says that Lacey can peel 26 oranges in 4 minutes. Adam can do 28 oranges in 6 minutes. Who is faster? So how would I set this up? Well, let's start with writing two ratios. First, the ratio for Lacey, which is 26 oranges in 4 minutes. And then we write the ratio for Adam. And for him, it's 28 oranges in 6 minutes. All right. So what's 26 divided by 4, and what is 28 divided by 6? Anyone? Well, 26 divided by 4, if you did it through long division, is 6.5, in this case oranges, per minute. And if you were to do long division on 28 divided by 6, you would get 4.67, 4.7, depending on how you round this. Let's just round this to 4.7 oranges per minute. Now, can someone tell me which one of these two is the quicker? Lacey is the quicker one. She can do 6.5 oranges in a minute. The lower number here is worse because that means Adam can do less oranges in a minute. So in this case, Lacey is the definitive winner. She can do more oranges in a minute. So if you needed some oranges peeled, you grab Lacey, leave Adam alone. Questions? Alright, next up we have, why are 6 to 9 and 20 to 3 equivalent? Can someone tell me that? Why are these two ratios equivalent? Because if you simplify them down, they're both the same thing. So when simplified, they are identical. And of course you have to prove this to me. So 6 over 9 I can write as, well, 6 is 2 times 3, 9 is 3 times 3, and 20 I can write as 2 times 10, 30 I can write as 3 times 10. And you can probably see here what's going to happen next. If I cross out 3, 3, 10, 10, I'm left with 2 over 3 here, 2 over 3 here, and of course, well, it's identical. That's how I can tell that they're equivalent. Simplify them, compare the simplest ratios, done. Alright, next. It says, are those two a proportion? How can we find that out? Well, if you said cross multiply them, I would very much agree with you. Very much. Totally. Alright, so yay, good. Now we have them cross multiplied. Let's go ahead and write our cross products. So our cross products in this case are 11 and 15. And I made a mistake. 11 and 18. And 15 and 14. That looks about right. So top left, bottom right, bottom left, top right. Yep. So what is 11 times 8 and what is 15 times 14? Sorry, 11 times 18. Well, 11 times 18 is 198. And 15 times 14 gives us a cool 210. Well, those are pretty close, but are they the same? They're not. Not proportional. So those two ratios are not equivalent, they're not in proportion. Questions about that? Alright, next up, let's see here. We have this problem here on the bottom left. You're asked to solve the proportion. What would you do? What would you do? Same thing that you did before. Cross multiply it. And then the rest is simple. The rest is cake. So my two cross products are in, I think I made a mistake here. Hold on. Yeah, I don't know how that W snuck up there for the near the 36. So the cross products are 36 times 4 equals to 16 times W. So what is 36 times 4? Anyone? $144. And my next step is to divide both sides by 16. So how many times does 16 go into 144? It actually comes out evenly. That's a nice one for a change. No decimals, it's 9. So that is W. That is my answer. Questions on that one? Next one's really easy. You're given a proportion, but the second part of the ratio is missing. And they're asking you, what can you place right there that would make that work? What can you do? Well, literally, you can have so many answers here. You can have hundreds of different answers here, and they would all be correct. What I would do is I would find the simplest way to get an equivalent ratio to 15 over 20. That's not 15 over 20 itself. So don't write the same ratio. Technically, yes, that works, but you're just copying. So don't copy. One thing you can do is reduce this. And I can reduce this easily by dividing both sides by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So 3 over 4 would work. I can also increase this. I can double both top and bottom. 15 times 2 is 30. 20 times 2 is 40. So I can write 30 over 40. So again, I can do so much here that would work. I mean, you can go into decimals, divide both sides by 2, 7.5 over 10. That would work. So again, I'm going to go with the simplest one, 3 over 4. And I do that by dividing both top and bottom by 5. But again, so many things would work here. It's kind of up to you what to write here. Questions? Next, you're asked to find the missing side in that rectangle. What would you do? I would set up a ratio and then find my missing ratio, part of the ratio or the proportion. Now here, be very, very careful because there's two ways you can write this. You can write this as 3 over x or x over 3. It does not really matter which way you write this, but if you write this as 3 over x if you put the side on top, this one has to be on top as well. Do not make the mistake of writing as 3 over x here and then writing it 15 over 10 here. That's not keeping it in proportion. If this one went on top, this one has to go on top as well. So 10 over 15. If you instead wrote x over 3, then you have to write 15 over 10. But if it's 3 over x, then it's 10 over 15. And what do I do next? Cross multiply. So my cross products are 3 times 15 and 10 times x. Alright, what's 3 times 15? 45. And this one's easy, even though it's a decimal. What's 45 divided by 10? Just take the decimal, which is right here, and just move it once to the left. 4.5. Easy peasy. Questions on that one? Alright, moving on. Moving right along. Here, a bit of a tricky problem. You are asked which of these two is not like the others. And I actually meant to make the middle one different. Again, like last time, I made a small mistake of my own and made this a bit of a tricky problem because they are actually all similar. Yeah, not exactly what I wanted to do, but if you take the top measurements and put them all in ratios, so pretend this is a really tough version of a similar problem you'll have on the quiz. The one on the quiz, I promise you, is going to be easier. And I've said this before. So 2 over 2.5. I'm just taking the top two sides again. Any two sides will work as long as you pick the same ones. Then if you pick 4 over 5. And then if you pick 6 over 7.5. Now these all look different. These all look different. But what if I try to compare them all to 2.5 as a denominator? What's the relationship between 5 and 2.5? It's twice as big. So if I divide this fraction or this ratio by 2, both top and bottom, I'm going to get 2 over 2.5. 4 divided by 2 is 2. 5 divided by 2 is 2.5. What's the relationship between 7.5 and 2.5? 7.5 is 3 times as big as 2.5. So if I were to divide both top and bottom by 3, I would get 3 over 2.5. And they're all similar. So, yeah. Sorry. I really meant for this one to be different. I will on the quiz. Well, maybe not the middle one. One of them will be. Alright, questions about that one? Alrighty then. So, next problem. 3 centimeters by 11 centimeters. I think we are enlarging the picture here. We're going from that size to 6 centimeters by something. What is that second by something? How will we find that out? Well, you can set them as ratios. So you can write 3 over 11 equals to, where does the 6 go, top or bottom? Top. And our missing measurement, we're going to mark it as C for centimeters, I guess. Doesn't really matter. What do I do next? Cross multiply, you say? I agree with you. And now you just write your true cross products. 11 times 6 equals to 3 times C, or 3C. What's 11 times 6? Easy. 10 times 6 is 60. 1 times 6 is 6. 66. Equals to 3C. And does anyone know how many times does 3 go into 66? Well, this one actually comes out nice and even, and it happens to be, let me make sure I'm not wrong, 22. Yeah, that sounds about right, 22. 22 times. So if you were to enlarge that picture, 3 centimeters by 11 centimeters is about the same as 6 centimeters by 22 centimeters. It even makes logical sense. 3 and 6, 6 is twice as big as 3, and 22 is twice as big as 11. So hey, logic. Alright, next up, we have a Pythagorean theorem problem here. So, what is that Pythagorean theorem? A squared plus b squared equals to c squared. Now, which one's missing here? Which side, which letter is missing? C. And how can you tell? Easily. The longest side is always in front of the right angle. Right angle is the biggest angle in a right triangle, and the longest side is going to be in front of the biggest angle. Kind of makes sense. Biggest angle, biggest side. So that's missing, that's C. Shortest side is going to be A, middle side is going to be B. These two, doesn't really matter, you can switch them around, but I just like to write A as the shortest, B as the second shortest. So I'm going to substitute now. 6 squared plus 7 squared is going to be c squared. What's 6 squared? And what is 7 squared? And all of those have to equal out to c squared. Now what is 36 plus 49? If you said 85, I totally agree with you. Now, unfortunately, 85 is not a perfect square. It just isn't. So, what can I do next? Next, I'm going to estimate. I'm going to try to find the root of 85, even though it is not a perfect square itself. So, C is the, let me find, because I always use purple for this. Yay, purple. Root of, which looks just like my blue. That's unfortunate. 85. Now, what are the two the two perfect squares that 85 is in between? (64) and 81. And 64 is 8, or the root of 64 is 8. The root of 81 is 9. So if 85 is in between 64 and 81, the root of 85 is going to be between those two, which is 8.5. So if you got 8.5, you did it. Great job. And I mean, it's a little closer to the 81, so it's more like 8.6 or 8.7, but close enough. And if you wanted to see the work on how we did that, again, I would highly suggest you go back and look at some of our estimating root problems, kind of like this one that we worked on right here. I just don't know what to do work here to estimate my root. All right, moving on. This problem here. What percent of 65 is 10? How would you set that up? Well, you first write your formula. And remember your formula. On the last quiz, I tried to trick you by giving you a find and fix it problem where one of the mistakes was the formula was off. And some of you used that wrong formula. So the percent over 100 equals to, and the part goes on top, and the whole goes on the bottom. Now what's missing? The percent is missing. What percent? That makes it super easy. So we're going to leave the percent as a p, and we're going to fill in the rest. So p over 100 equals to, now what's the part, what is the whole? What percent of 65 is 10? 10 is the part, 65 is the whole. So 10 on top, 65 on the bottom. Oops. And by this point, you probably know how to deal with a proportion that has a missing value. You cross multiply. P with 65, 100 with 10. So those are my two cross products. So P times 65 equals to 100 times 10. Now what's 100 times 10? 1,000. That's easy. Next part, less easy. How many times does 65 go into P? This one does not come out evenly, and I apologize for that, but again, practicing with decimals is okay. It comes out to be 15.38. I'm going to round it up to 15.4. That's fine for our use. Now, last but not least, logic check. 15.4% of 65 is 10. Well, 15.4% is not a large percentage, and 10 is not a large part of 65. It makes logical sense to me. So, passes the logic check. Questions? Next problem's pretty similar. So I'm going to go ahead and quickly write up the formula. Percent over 100 equals to part over whole. Again, remember this formula for the test. I'm not going to give it to you. You have a few formulas to remember for the test. This one, the Pythagorean Theorem, so don't get them mixed up. Now here, what is missing? This one's super simple. 45 is 25%, so the 45 is the part because it corresponds to the percent. So the part that's missing is the whole. I don't have the whole. I have everything else. I have the percent and the part. So it's going to be 25, let's see, over 100 equals to, the part here is 45, and I'm missing for the whole. So I'm going to put a W there. Cross multiply this, and we are going to get 25W equals to 100 times 45. I'm going to continue working right over here. What is 100 times 45? Well, it's going to be 4,500. It's 45 with two zeros. And how many times does 25 go into 4,500? Fortunately, this one comes out nice and even. 180. Logic check. 45 is 25% of 180. Sure, it makes sense. 25% is about a quarter, and 45 does seem to be about a quarter of 180. I mean, right about there. So, because 45 is half of 90, and two 90s fit into 180, yeah, that actually makes perfect sense. Questions about that one?